Thanks for joining us today. I have Andrew Garchek with
Hello.
us today. Hey, Andrew. We're going to do, I guess, continue our media video series on Ask an Engineer. And today we're going to go over some different types of parts and some different filaments and why those applications would fill in for different projects. So
Sounds good.
Thanks for joining us today, Andrew.
Yeah, no problem. Happy to join you again for another amazing episode.
Sure. And congratulations on MIP. I know it turned out great, and I heard your presentation was really, really good.
Thank you. It was good. I had some technical difficulties. My headset failed, and I couldn't get my slides up in the beginning, but I persevered, and I think it came out well. And kudos to you as well, because you and Dan did a great presentation, from what I understand, on that 3D printed drone.
Oh, thank you. Yes, it did turn out very well. That was a great project to be a part of, and a lot of fun.
Happy it happened, and I'm happy it's over.
Yeah, exactly. A successful event. So with part of the beauty of working virtual, we're going to go over and look at some parts. So Andrew, do you want to kick us off and show us some things that you have?
Yeah, so first thing, just before we jump into the parts, I think I could very quickly just explain the process. So basically, all the parts I'm showing you today have what's called continuous fiber. And you may have heard of like carbon fiber and other 3D printed materials, but that's chopped carbon fiber. It's almost like a powdered carbon fiber that they blend in. So it's not a real composite, it's actually a plastic. But what I'm talking about is adding a continuous strand of fiber into plastic, which is night and day. This adds so much strength, so much material properties. So this is actually a part that I stopped in the middle of the build just so that you could see what's going on. But the black material is the plastic. It's actually a carbon-filled nylon, like I was just talking to you about, with like powdered carbon. But
Sure.
This yellow bit that goes around the perimeter, this is a continuous strand of Kevlar. So that makes this part, way more, much higher defense against like impacts. It's Kevlar, right? Think bulletproof vests, right? High impact. That's what those applications are for.
Sure.
But there's other fibers. There's carbon fiber. There is Kevlar. You've got high temperature fiberglass, and you've got, I guess what we call regular fiberglass. So that's kind of what I want to show you today.
Okay, great. Yeah, that sounds great.
So I think first, why don't we take a look at a part in the SolidWorks software?
Sure.
And this is the part. This is the part in question, right? This is the one we're going to show. This is a soft jaw. So this part holds a part so that it can be CNC'd, milled, or turned in a lathe or something like that. And maybe real quickly, you could tell us what would it take to design a part like this as we show this in SolidWorks?
Okay, sure. Yeah, let's take a look at that. Let's jump over into our SolidWorks environment and take a look at this part really quick. Okay, now we have the model open in SolidWorks. The file looks pretty good. Looks like this is going to turn out to be actually a great print. I don't see any issues that will cause us a problem during printing. Everything looks very nice and smooth. Looks like we're going to have a minimal amount of, actually, we shouldn't have any support. So let's jump over back to Andrew, and he could take it from there. All right. Thanks, Andrew, for the file. All right, great. So that was a really great representation there to see in SolidWorks. Andrew, could you explain a little bit more what you were about that?
Yeah, absolutely. So this is a set of what are called soft jaws. So these hold apart so that you can machine it. Because if you're going to make, let's say, like a valve or something, you have to cut the threads, but you need something that matches the geometry to hold it in place as you take one out and another one in. So that's what we have here. Open this up. I've actually 3D printed the part in metal that is actually held in there. So you can see this is kind of what you would be working on. But to work on this, you would need this set of soft jaws. So hold it in here.
And Andrew, what are the soft jaws? What kind of material is that made out of?
So this is called Onyx. This is a carbon-filled nylon. And then in order to make this strong enough for this application, see, that's the key. You can't really make these with PLA or ABS. It's not strong enough. To make this strong enough, we added continuous fiberglass. So that is added in here to give it additional strength. The fiberglass makes this material about 10 times stronger than it would be without it. So it really makes it night and day and allows you to do applications like this. I would say fiberglass is really good for like general tooling applications. So like soft jaws, or I have another part here to show you. This is a Cmm Inspection Fixture. So the way that this would work is the company that makes these connecting rods for your engine, they might pull out 1 out of 100 or 1 out of 1,000 or 1 out of a batch. And basically they'll put it onto an inspection fixture like this, and they'll run a coordinate measurement machine, CMM scan over it, and then they get a scan that they can look at in their software, and they can determine if this is of the highest quality.
Wow.
So this would also be, I would use regular fiberglass for this.
Wow.
Now, another choice is carbon fiber. And you might say, well, carbon fiber, you know, I'll tell you now, it makes it about 20 times stronger than the plastic, and the fiberglass is only 10 times stronger. So why wouldn't you use carbon fiber? And the answer is it's economical. The carbon fiber costs twice as much as the fiberglass, and for applications like this, there might be some where you use carbon fiber, but I think for most of them, it's probably a little bit overkill.
Okay. Okay, great. Great. So, Andrew, if I could ask you just a couple questions. So, out of those different types of filament that you were just going over, do you have any preferences of what you like to print with more than others? Do some of those have any kind of any different material properties where they warp or shrink while you're printing?
Sure. So I print mostly in the material that I was just showing you. It's called Onyx. It's the generic name is carbon-filled nylon. And what I really like about this material is the surface finish. I mean, you get great surface finish. You get really good accuracy because nylon is a great 3D printable material. It has great layer adhesion, but this nylon has carbon in it. And the carbon gives you other properties, and those are resistance to UV light. It gives it higher strength. It gives it good resistance to chemicals. So especially for like an application like this, like a set of soft jaws, they might be pouring cutting fluid on top of this as they're cutting this part. So it has to be resistant to chemicals. So that's why I like this Onyx material. It's good in a lot of categories as far as being like a rugged plastic that's good for like manufacturing, you know.
Great.
But then it gets even better when you put in like this part has continuous carbon fiber in it.
Wow.
So what's going on with this is a piece of end of arm tooling, and it's got these channels through it. So they connect a tube here for air and some suction cups on the bottom, and this goes around and it picks up their parts and it moves them around like that. The problem they were having was that on the very tips, the very ends of this part, it was deflecting. They were printing it out of like a PLA or something like that, and it was deflecting. So the parts in the middle would work really well, and at the end it wouldn't work too well. So they switched to a solution like this where they put continuous carbon fiber. They put a loop around the edge here, and now this is much stiffer. And that's what carbon fiber is great at. It's really stiff, really high strength to weight ratio too. So for end of arm tooling, it allows the tool to move much faster, you know, for higher cycles. But the stiffness was really what sold these guys. And, you know, hard to show it in a video, but this one's stiff. And if I use more fiber, I could make this a brick. I mean, I could make this where you wouldn't even be able to deflect it with all your might, even one bit. So definitely carbon fiber has its uses for sure.
Sure. That's super cool. So incorporating that continuous carbon fiber in the X and Y axis really stiffens out that part. That's what you're saying. It really makes it nice and strong and also light.
Yeah, absolutely. So, you know, as you know, you're a 3D printing guy. You know, you're getting a lot of strength in the XY. But you can also create resistance to bending in the Z direction by creating a cross-hatched pattern with the fiber. So on every layer, it's going to change the fiber till it's like a net. Picture like a net, basically. So, if you were a trapeze artist and you're flying around and you're going to land on a net, you don't want to land on a net like this. You want to land on a net like that.
Right.
So that's what it is. It's that cross-hatching that causes a resistance. And also, you can do it in another way with stacking fibers. So if you were to stack like rings of fiber on each other, they would also be good in compression in the Z direction. So with a lot of this stuff, it's really, you got to look at, is it tensile stress? Is it a compressive stress? And then the orientation, which is really important. I know we're probably going to do another video just on orientation, but the way you turn it and then the placement of the fibers will really determine if your part is going to completely fall apart or if it's going to work.
Great. Thanks for that explanation. That makes complete sense. And more so of a great application for that continuous fiber will be like around bolt holes or circular patterns where you might have some expansion or compression from bolts possibly going through one of your parts, correct?
Yeah, absolutely. One common way that folks use the fibers is they'll put a stack of rings around like a bolt hole. So when the gorilla who works at the facility is, this is 3D printed, I'll show them. I'll tighten this down until it breaks, and he tightens it, but the fiber's there to prevent that. So you can actually reinforce bolt holes really well. And then there's another fiber, which I didn't mention yet, which is high strength, HSHT, high strength, high temperature fiberglass. And this is a mold, a thermoset mold, which is printed in that carbon-filled nylon. But then we add high temperature, high strength fiberglass to this part. It does two things. One, it raises the heat deflection temperature. So you actually get a more resistant mold. But actually, I forgot to mention that before. That's another really good quality of this onyx. It's 145 degrees Celsius heat deflection temperature, and it goes up when you add the fiberglass. Wow. But also, it's that as much as the strength. This is now 10 times stronger. So if this mold is under some forces and some pressures and some heat, it can take a lot of that. Would you like to see how I add the high temperature fiberglass to this?
You read my mind. I would love to.
Okay, why don't we shoot over to Iger for a moment, and I'll show you how that works.
That sounds good.
Okay, now I'll be showing you how to add the high strength, high temperature HSHT fiberglass into that thermoset mold that we were just looking at. So this is Iger. This is the proprietary software from Markforged. First thing, we're just going to log in, and then you get your parts library here. And we'll click on the part, bring that up. Now to add that extra fiber, we're going to go to the fiber menu here and pick high strength, high temperature glass. And we can go now to the reinforcement tab, and we can actually do a little bit of a preset before we dive in to the actual part. So we can choose how many layers we want to affect, which type of pattern we want to use, how many rings. I'm just going to keep it with most of the defaults here. Hit save. Now you do have to save it because it is cloud software. So this is now being sliced in the cloud on a Markforged server, I presume. So it does take just a few moments here to load up. And as soon as this is done calculating the pathing, then we'll go to the internal view where you can see a little bit more clearly all the fiber added. Neat thing too, every time you save, there is this tab on the left here, which is your old versions. So every time I make a change, I could always go back, look at the old version, and revert to that. And then it also shows how many times I've printed it. So I can go back and look at every single print. Wow, quite a few here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Print this 9 times. This is a common part with our sales team, so I'm not surprised that we've printed this so many times. But you can look at old print jobs, you could look at old versions, and the metrics as well, which are going to fill in as soon as it's done adding all of this fiber. Now it is cloud software, like I mentioned, so you're kind of at the mercy of your internet connection at the moment. Looks like we're running a hair slow right now. but it is moving along. Some of the other fiber options here, while we got a second, you can add concentric rings. So the way I just told it to add the fiber now was to add concentric rings, but also a fill in the middle. So it's going to fill in the center of the part as well. But if you want to add more concentric rings to have less fill, or less concentric rings to have more fill, you can do that. You can change the angles of the fiber, which is pretty cool. So basically the way I have it set now, 0, 45, 90, 135, it's going to alternate. So on each different layer, it's going to change the angle, creating a cross hatching, which is really great for resisting a force in the Z direction. Okay, now it's done slicing, so we can actually go into the internal view. And now we're going to see a really cool X-ray-esque version of the part. And the gray, which you kind of can't see at this point because it's see-through and there's so little, is the plastic. And the orange is the high-strength, high-temperature fiberglass, which I have loaded to the maximum. That's why all you really see is orange, because this part is now mostly just, the fiberglass in there. And if we look at the 2D mode, we can actually look layer by layer. So this is the first layer, which is gray, so it's all plastic. Second layer, third layer, fourth layer. Then on the fifth layer, it starts with the fiber. And this is where I was talking about the concentric rings, which run around the perimeter. And then this is the isotropic fill in the middle. And like I mentioned, if we actually toggle to the different layers, you can see the angle changes, creating that cross-hatching. So whenever your part's ready, then you hit print. And you've got your part on the tray. Why don't we just add a second one just for fun? The software will actually place the part with the most efficient path of the nozzle, so that's where it likes it. And then from here you would just actually choose print and then choose your printer, and then hit print. And away you go. And that's how it's done.
All right, and we're back. Thanks, Andrew, for going over that. That was really great. Maybe we could do another video on Eiger itself and just go over some of the slicer settings. That would be, I think, really helpful as well. I know Eiger can compare it to a lot of other slicers out there, so there's a lot of the settings that we could possibly go over in another video. So the HSHT, do you use that in any other kind of application?
You know, it's funny. I would say it's probably one of the lesser used fibers in my, and what I do. Carbon fibers, kind of like the big one. But I do have another example here, which I wanted to show you.
Great.
So this is a little setup I made showing off a welding fixture, right?
Okay.
So normally you got a welding torch, you get a little too close to your plastic, there it goes. But with this material, we've added the high strength, high temperature fiberglass. So it's 10 times stronger. So it can actually act as a fixture the way it needs to with the strength.
Sure.
But it's also resistive to those, the temperature, the heat coming from the welding torch. So it allows you to get closer and really make this effective as a material for this application.
Wow, that seems like some incredible material. That's really cool. When you just think about the application that you're going to use that in, it's pretty extreme.
Yeah, it's really into the world of manufacturing, right? It's coming from hobbyist 3D printing, and now with these types of materials, you can take that next step into, jigs and jaws and fixtures and all these things you couldn't do before. So,
Great.
Yeah, it's neat stuff.
Great. That is awesome. That is so cool. So yeah, that was the explanation of all the different types of material. I'd like to thank you, Angie, for taking your time today and going over all those parts with us. I'd like to thank the audience for joining us as well. Anything else you'd like to add, Andrew?
I would just like to say thank you, Brelan. You're an excellent moderator. Thanks for the interview today.
Sure, anytime. Well, thank you guys, and we'll see you on our next video.
Thanks, everybody. Have a good one.